We will learn about the indifference curve theory in this module. The theory of consumer behavior based on the ordinal approach was propounded by J.R. Hicks and R.G.D. Allen in 1934. According to this approach, utility cannot be measured in any quantifiable number. It could only be measured by giving order, ranks or preferences. Hence, the ordinal utility means consumers' preferences or choice for one commodity or for a basket of goods over the other. Here the preferences could be expressed in terms of more or less preferable. Moreover, since the consumers have a limited income which they can spend on their consumption, therefore, in this approach, a consumer will prefer a basket of goods over the other given the prices of the goods and the income of the consumer. This would be explained with the help of the budget line and indifference curve later in this chapter.
After studying this module, you shall be able to know the concept of ordinal utility, budget line, and indifference curve. Learn how to measure the utility by giving preference. Identify the consumer equilibrium where the consumer finds optimum combinations of two goods which give him maximum utility given his income. Evaluate the changes in consumer equilibrium when the prices or income changes. Derive the demand curve from ICC and PCC. The ordinal utility theory is based on the following assumptions. First, rationality. Second, finite money income. Third, ordinal utility. Fourth, transitivity and consistency of choice. Non-satiety. Sixth, diminishing marginal rate of substitution. Now, we will understand what does rationality means. A consumer is always rational, that is, he always prefers more of goods and services to derive maximum utility. Thus, he always buys the commodity which gives him maximum utility first, and then he buys the least utility giving commodity at the end. Next, we have finite money income. The consumers have limited money income which they spend on the purchase of all the goods and services for their living. Thus, they allocate this income as their consumption expenditure on all goods and services. Ordinal utility. The utility derived from the consumption of each good or a basket of goods could be measured ordinally by giving preferences for each good over the other. Next, we should understand transitivity and consistency of choice. Consumers' preferences are always transitive. That is, if a consumer prefers good X over good Y and the same consumer prefers good Y over good Z, then according to this assumption of transitivity, he must prefer good X over good Z also. If X is greater than Y and if Y is greater than Z, so X must be greater than Z. Whereas, as per consistency of choice, if a consumer prefers good X to good Y in one period, then he must not prefer good Y to good X in another period, or must not treat both the goods as equal. Symbolically, if X is greater than Y in one period, then Y is greater than X or Y is not equal to X in other period. Non-satiety. According to this, A consumer always prefers more of a good or larger quantity of all the goods because he has not reached the saturation level nor he is oversupplied with all the goods. Moving on to diminishing marginal rate of substitution. Marginal rate of substitution refers to the rate at which a consumer substitute one good X for the other good Y so that the level of utility or satisfaction obtained from it remains the same to him. Symbolically, MRS is equals to change in X divided by change in Y or change in Y divided by change in X. According to this assumption, as a consumer continues to substitute X for Y or Y for X, his MRS diminishes or decreases. The next important concept is indifference curve. Indifference curve is defined as the locus of the points of the different combinations of different goods which gives an equal level of satisfaction to the consumer. Therefore, a consumer is indifferent between any of the combination which lies on the same indifference curve. This happens because the consumer has a power to substitute among various goods given their prices and his income level. For simplicity, let's take the example of two goods X and Y. Now, given the income of the consumer and the prices of X and Y, the consumer can choose different combinations of X and Y to be consumed in order to maximize his satisfaction. All those combinations of X and Y which gives an equal utility to the consumer forms an indifference curve. Moreover, the consumer can substitute between X and Y and thus can either consume more of X or more of Y, but the main point is that the level of satisfaction arising from the different combinations of X and Y remains the same to him. We shall now understand indifference curve graphically. As has been depicted in the above figure, that at point A, the consumer consumes Y3 and X1 combination of goods, whereas at point B, he substitute Y with X and the combination at point B becomes X2 and Y2. Similarly, at point C, the consumer consumes X3 and Y1 combination of both the goods given his income and prices of X and Y as Px and Py. However, all the points A, B and C gives the consumer equal level of satisfaction. Hence, he is indifferent among A, B and C. Therefore, the curve joining A, B and C is known as indifference curve, where the consumer is indifferent of the different choice which he has as they all gives him equal level of satisfaction. Here, only the combinations of X and Y are different at each point, but the level of satisfaction which the consumer obtained from them is the same. Now, if the consumer either consumes more of good or of both the goods, then he would be able to increase his level of satisfaction and thus a new indifference curve would be drawn above this indifference curve, which represents the different combinations of X and Y, which is higher than the previous combinations and which gives him the same level of satisfaction as compared to the previous level of satisfaction. Similarly, a lower indifference curve would represent the combinations of x and y lesser than the previous combinations, which gives him equal satisfaction. Hence, the higher an indifference curve, the higher is the level of satisfaction, and the lower the indifference curve, the lesser is the level of satisfaction obtained by the consumer. Representation of the different combinations of goods and different level of satisfaction on a graph is known as an indifference map. Further, we will discuss marginal rate of substitution. Marginal rate of substitution is defined as the rate at which a consumer substitutes one good for the other, obtaining the same level of satisfaction. In this case, it is the rate at which a consumer substitute good Y with good X in order to get the same level of satisfaction. Symbolically, MRS Y and X is equals to change in Y divided by change in X, or MRS X and Y is equals to change in X divided by change in Y. MRS is also known as the slope of the indifference curve. Understanding marginal rate of substitution graphically. As we can see from the diagram below, that as the consumer consumes more of X, he reduces the quantity of Y from Y3 to Y2 in order to get the same level of satisfaction. Similarly, he further substitutes Y from Y2 to Y1 with good X in order to get more of X and the same level of satisfaction. This rate of change in Y due to the increase in the quantity of X by 1 unit is known as marginal rate of substitution. As we can see, an indifference curve has a diminishing marginal rate of substitution, means that the consumer substitute X for Y at a diminishing rate. In other words, as the consumer increases the consumption of X by 1 unit, their consumption of Y reduces at a decreasing rate. Hence, we can say that an indifference curve has a diminishing slope. As we can see that change in x1 is equals to change in x2 is equals to change in x3 is equals to change in x4, but change in y0 is less than change in y1 is less than change in y2 is less than change in y3. This marginal rate of substitution falls because of the following reasons. Diminishing marginal utility. The decline in the ability of the consumer to sacrifice a commodity whose quantity goes on declining. Indifference curve has the following properties. ICs have a negative slope because of the diminishing marginal rate of substitution. ICs never intersect with each other, else they will break the assumption of transitivity. IC is convex to origin for the imperfect substitute goods. A higher IC represent higher level of satisfaction. Now we will understand the shape of indifference curve for different type of goods. First, we have substitute goods. Substitute goods are those goods which give the same level of utility to the consumers. That is, they can be substituted in place of their related good as they possesses almost same characteristics like their related good. In other words, two goods are considered as substitute goods for one another when the utility derived from both of them is same. For instance, wheat and rice, Coke and Pepsi, etc. Therefore, the marginal rate of substitution between substitute goods is constant, as change in Y is equals to change in X. So, marginal rate of substitution is equals to change in Y divided by change in X. In this case, we can write marginal rate of substitution is equals to change in X Divide by change in x, because change in y is equals to change in x, therefore marginal rate of substitution is equals to 1. Next, we have complementary goods. Complementary goods are those goods which are consumed in fixed proportions like pen and refill, left socks and right socks, car and petrol, etc. In such a case, if we even increase the quantity of one good, the quantity of other good does not increase. Hence, marginal rate of substitution is equals to 0. Symbolically, marginal rate of substitution is equals to change in y is equals to change in x. But in such a case, change in y is equals to 0 and change in x is equals to 1. Thus, marginal rate of substitution is equals to 0 divided by 1 is equals to 0. Case when one good is necessary. In case of one good is a necessary good without which we cannot survive, like water, then in such a case the shape of the indifference curve would be as shown in the diagram. In case of a bad good is defined as a good whose excess is bad for the consumption. That is, if the consumer will consume more of it, then his utility would decrease. For instance, cigarette for a mediocre or non-smoker. In such a case, the shape of the indifference curve is as shown in the diagram. Hint: in order to draw an indifference curve, always find out the worst point of both the goods and then bend the indifference curve towards that common worst point. As in this case, the worst of y is 0. However, the worst of bad is the excess. Therefore, the indifference curve bend away from 0 towards x-axis. In case of a neutral good, neutral goods are those goods which neither yield utility nor disutility to its consumers. Thus, a consumer is indifferent to its consumption. In such a case, the indifference curve will be a straight line as shown in the diagram. When a good is turning bad after some point. If a good is a normal good till some point and then after that point it becomes bad for its consumer, that is, it provides utility to its consumer till some point, but after that point, if the consumer still consumes it, then it starts providing disutility to him. Then, in such a case, the indifference curve is as shown in the diagram. We have seen that indifference curve is tool through which a consumer can measure his utility of consuming goods. But in real life, a consumer is always constrained with two things in order to maximize his utility. One is his limited money income and the other is the price of the commodities. Both limited money income and the prices of the goods act as a constraint to the utility maximizing behavior of the consumer. This is known as budgetary constraint. Symbolically, Px into x plus Py into y is less than equals to m. This equation is known as budget line of a consumer where Px and Py are the prices of the two goods x and y. X and y are the respective quantities of x and y which a consumer consumes given his money income m and the prices of these goods. Hence, according to this budget line, a consumer always decide about how much quantity of goods to be consumed based on his money income and the prices of the consumer. Then, from this set of goods, he tries to choose which combination would give him the maximum utility. Now, if we just adjust the above budget line equation for x, then we get x is equals to m divided by px minus y into py divided by px. Here, this minus py divided by px is also known as the slope of the budget line. Now, if x is equals to 0, then y is equals to m divided by py. And if y is equals to 0, then x is equals to m divided by px. Here, this minus py divided by px is also known as the slope of the budget line. Now, if x is equals to 0, then y is equals to m upon py. And if y is equals to 0, then x is equals to m divided by px. On plotting these points on a graph, we get the following curve as the budget line. Good x and good y are shown on x-axis and y-axis respectively. Budget line is the required budget line. Hence, as per the budget line, all the points which come inside or on the budget line represents a feasible area as given the income of the consumer and prices of the goods the consumer can consume any combination. But if the combination cost more than his given income, then that will fall outside the budget line, which is represented by infeasible area in the above graph. Thus, the budget line is drawn based on the money income of the consumer and the prices of the goods. Therefore, if any of these factors changes, then the budget line will also change. If the money income of the consumer changes, then the budget line will shift either outside or inside as shown in the diagram. As it can be clearly seen from the above diagram, if the money income of the consumer changes from M to M dash, the budget line moves upward as now with more of his income, he can consume more of both the goods and vice versa. Now, if the prices of the goods changes, then it will pivot the budget line as shown in the diagram. As it can be clearly seen from the above graph that if the price of x increases from px to px dash, then given his money income m, he will reduce the consumption of x as now x has become expensive. However, he will continue consuming the same quantity of y. Hence, the budget line will pivot inward to B2. Similarly, if the price of x reduces from px to px double dash, then he can increase his consumption of x as now given his money income m, x has become relatively cheaper. Hence, the budget line will pivot outward to BL1. Moving on to how consumer equilibrium is achieved. A consumer attains equilibrium at a point where he maximizes his utility from the consumption of goods, given his money income and the prices of the goods. According to the ordinal utility analysis, two sets of conditions must be fulfilled for a consumer to attain equilibrium. These two conditions are as follows. Necessary condition. As per this, MRS must be equal to Px by Py, that is, the slope of the budget line must be equal to the slope of the indifference curve. Sufficient condition. The necessary condition must prevail on the highest indifference curve. Hence, consumer equilibrium is attained where the above mentioned two conditions prevails. Next, we will understand how consumer equilibrium is achieved graphically. Consumer equilibrium is achieved where the highest possible indifference curve is tangent to the given budget line. In the figure, three indifference curves have been drawn. The maximum possible indifference curve that is tangent to the budget line is IC dash. As represented in the above diagram, E is the equilibrium point where the slope of the budget line and that of the indifference curve is the same. Thus, the consumer will consume Qx and Qy quantity of x and y in order to maximize his utility given his money income M and the prices of x and y as Px and Py. As we can see that the equilibrium take place on IC dash, it does not take place at IC nor on IC double dash. The reason for this is that indifference curve comes in the feasible area under the budget line, but the consumer does not maximize his utility on IC because he has a higher income, and thus using that income he can increase his consumption of both the goods and can move to IC dash. So on IC dash both the necessary as well as sufficient conditions apply. However, if he further moves from IC dash to IC double dash, then all those combinations lying on IC double dash are not feasible because his money income is less. All the points on IC double dash would definitely give the consumer a higher utility as compared to the combinations lying on IC dash, but the combinations on IC double dash are not attainable. Hence, the consumer equilibrium cannot take place on IC double dash 2. As we have seen in the above section that consumer equilibrium happens at the point where the indifference curve is tangent on the budget line, but when the income of the consumer changes, then the budget line also changes and correspondingly the IC also changes. For instance, if the income of the consumer increases, then the budget line will shift upward. This represents that now the consumer can afford more of both the goods, hence his IC will also shift, and the tangency of the new IC with this new budget line gives new consumer equilibrium. Similarly, if the process will go on, then the equilibrium points will keep on changing. If we connect all these equilibrium points with a line, then this line joining all the equilibrium points is known as income consumption curve, which shows the changes in the consumer equilibrium due to a change in the income of the consumer. If we connect all these equilibrium point with a line, then this line joining all the equilibrium points is known as income consumption curve, which shows the changes in the consumer equilibrium due to a change in the income of the consumer. This is represented in the following diagram. The above is the case of the normal goods. Here, normal goods are the goods which show a positive relationship between the demand of the good and the income of the consumer. That is, if the income of the consumer increases, his demand for normal good also increases and vice versa. However, in case of inferior goods, the ICC would not be upward sloping because inferior goods shows an inverse relationship between the demand of the inferior good and the income of the consumer. That is, if the income of the consumer increases, his demand for the inferior good reduces. In such a case, the ICC would be downward sloping as shown in the diagram. As has been represented in the above diagram, as the income of the consumer increases, his demand for the inferior good reduces and that of the normal good increases. Hence, based on this, his budget line is shifting and IC is also increasing, but the combination which he chooses for each increased income comprises of less of inferior good and more of normal good in order to maximize his utility. We can further derive the demand curve for a good based on his ICC. With an increase in income, budget line shifts from PQ to P-Q- and with further increase in income, it shifts to P-Q. We have three equilibrium points corresponding to each budget line, that is E, E dash, E double dash. As shown in the figure, by combining points E, E dash, E double dash, we get the ICC curve. By dropping these three equilibrium points on the graph below at point A, B, and C in the lower graph and corresponding to a given price, we can get the demand curves. Note that here we are only showing how to derive the demand curve of the normal good. You can also derive the demand curve of the inferior good in the same way. Clearly, for a given price of a good, if the income of the consumer increases, he demands more of good X. This gives point E, E dash and E double dash, and three different demand curves emerges with ICC for good X. Note that here we can see that the demand curve is downward sloping, representing an inverse relationship between the price and the quantity of the good. If the price of any of the good changes, then this leads to a change in the consumer equilibrium too. For instance, if the price of X falls, then this will make X relatively cheaper and the consumer will demand more of X and same quantity of Y, and thus this will pivot his budget line outward. But when budget line pivots, then consumer will change his combination of goods which will maximize his consumption. Now his new basket of goods will comprise of more of X and less or same quantity of Y. Hence his IC will shift upward too. The tangency of the new IC with the new budget line gives the new equilibrium point of the consumer. Joining all such points gives the price consumption curve known as PCC. Joining all the equilibrium points gives the price consumption curve PCC. This is depicted in the diagram. The above is the case of the normal good, where normal goods shows the inverse relationship between the price of the good and the quantity of the good. That is, if the price of the consumer falls, its quantity consumed or demanded increases. However, if there exists a positive relationship between the price of the good and the quantity of the good, then that type of good is known as given good. In such a case, if the price of the given good falls, its quantity also falls. This is depicted in the diagram. When price of the given good falls, the budget line shifts from PQ to PQ1, but quantity demanded decreases from C to B. With further decrease in the prices of the given good, budget line shifts to PQ2, which further decreases the output to A. Hence, we have three different equilibrium points for each of the budget line. In the above diagram, we can see that if the price of the given good falls, the budget line pivots outward, but the quantity demanded of the given good reduces, and hence the points joining the consumer equilibrium, that is E, E dash, E double dash, gives a downward sloping PCC. We can derive demand curve from PCC as shown in the diagram. In the above diagram, when price falls, the budget line shifts outward from PQ to PQ1, and with further decrease in prices, budget line shifts to PQ2. Joining the equilibrium points of all the budget lines, we get the PCC curve. The above graph clearly shows that as the price of X reduces, budget line pivots outside and then the quantity of X increases. When these points are drawn below at points X1, X2 and X3, then corresponding to prices P1, P2 and P3, then they form demand curve for X, which is downward sloping.
Now, let us summarize what we have learned. The entire chapter has explained how the utility can be measured in terms of indifference curve. This has also explained how the consumer attains his equilibrium with the help of budget line and indifference curve. Then we have seen how the changes either in the price or in the income of the consumer affect the changes in his equilibrium, and then we have also derived the ICC, that is income consumption curve, and PCC, that is price consumption curve, and from PCC and ICC we have also derived the demand curves.